Now let's look at how these components are connected together on schematics. Wires on a schematic are usually what's referred to as a node. And what a node is one or more electrical connections between components. So a wire is not a single wire or a physical wire on a schematic. It is one place where a bunch of components are connected together, right? It's usually not named. It's usually just a line that goes between components on a schematic. Here's an example of a schematic that uses nothing but wires. And you can see that this particular wire, there's a wire that goes here, then it goes down here, and it also goes there. So this particular wire, or this node, connects this diode, this transformer, that resistor, and that particular pin on the integrated circuit. So that particular wire actually does a whole bunch more things, and it's not just one wire. It's not just a physical wire. It's a logical connection. That's why the circuit design software often refers to it as a node rather than a wire. Now, in really big circuits, if we have a lot of connections that we need to make, the schematic can get really crowded. So rather than have every wire run individually, we can do something called buses, where we bundle all of these nodes together and we name the nodes on entry and exit to the bus. And what that looks like is something like this. So here we have a bus of 4 signals, DAT00 through DAT03, and those individual wires all connect with a bus, which is this big bundle, this big fat wire, using bus entry components. So what this does is in the software, we're saying wrap all these together and pipe them wherever this big fat line goes, right? So we can make a much cleaner schematic by bundling these all together. And then once they enter, we have to get them to exit. So we use bus exit components and we peel those off. And the way we know which one we're peeling off is we name the signals. We name the wires the same thing going in and going out. And we can do awesome things like, instead of having to go in the same order, we've got DAT0 through DAT3 here. Now we've got DAT3 through DAT0. We don't have any wires that are crossing each other. We just have a nice sort of clean layout, and everything works out really nicely, right? So this is a way to make our signals a lot more, or our schematics a lot more readable. Here's a bigger schematic. The same sort of thing is happening, where we have bus entries with named signals A through K, and then we have bus exits, all crazy and out of order all along here. And you can jump on and jump off of the bus anywhere you want, and this helps make these schematics more organized and easier to read. Now, signals are named nodes. So basically, when we were using the buses, we were using the buses as named nodes, so that, or using the wires as named nodes. So by giving them a name, we're making a reference, we're making a connection logically in the schematic using the software that connects the two things. Any nodes with the same name in a schematic are connected, right? So the idea here is that this is a logical connection that happens in the software, and the software keeps track of it without actually having to draw it on the schematic. So we need to keep that in mind as we're doing this. These signals that just sort of jump across are way more commonly used than buses these days. I used to see lots of buses. Now I see very few buses and lots of signals in the schematics and documentation that I'm looking at these days. So these are more commonly used. And well, often the best example is the 5-volt and ground supply signals. These are signals where all of the 5 volts are connected together, all the grounds are connected together, that sort of thing. And that's something we see commonly in circuits. Here's an example of a circuit that has 3 different kinds of supply buses, or supply signals. So there's a 3.3 volt, there's ground, and there's a 5 volt too. So this circuit is working between 2 different kinds of voltages. And you'll notice some other signals as well. So the supply signals tend to have their own symbols that represent a connection between the two, but for things that are just regular signals that we need to connect together, we just name them and then end the line. So this SCK signal is actually connected to the SCK down here. And you'll notice there's a bunch of other signals that are defined here. Here's MOSI, that's connected in 3 places. It's connected here once, it's connected here once, and it's connected here once. If we had all of these wires running between here, it would be a big rat's nest and there'd be no clear way to follow it. So just by naming the signals and having them sort of jump across between them, we're making it clearer without getting people confused about how they're connected together and stuff like that. So signals are really handy for making these clear schematics. And that's the main point of schematics, is to make clear communication about how a system is laid out, how a system is connected, so that we can write software that takes advantage of that.